Hello, everybody, and welcome back to the Math Puzzle Crash Course. We have a mixed operations problem that I've seen this one show up online in some different forums, and it's a pretty simple one, but it mixes addition and multiplication. However, I've seen a lot of incorrect answers on this one. I'm seeing a lot of people, I'll just say it right off the bat, answering 15, which is incorrect. So I'm going to give you a little heads up on this one. But if you would like to try to solve it, and we can come back and work this one out together, and I can explain to you how you go about getting the correct answer. So you can pause, and we'll be right back. All right, so first of all, again, we're going to cover this. I've covered this in many other videos concerning the order of operations, but multiplication has precedence over addition and subtraction. There's a lot of confusion and misunderstanding over that. A lot of people think that you've got to have parentheses or brackets, depending on what you want to call them, around the multiplication. But the truth of the matter is, you do not need parentheses or brackets to give multiplication precedence. Multiplication already has precedence over addition. And the reason is it's multiplication is simply repeated addition. So it's a kind of a shorthand, compact way of writing out a bunch of addition. And so you need to resolve that first before the addition. So there's a reason behind this order of operations. So understanding that, you know that 1 times 5 is 5. So 1 plus 1 plus 5 is 7. And that is the correct answer to this problem. All right, so here we have another way to look at this is, I've just said that multiplication is shorthand for repeated addition. So you're doing this multiplication first. So 1 times 5 is 5, 1 plus 5 is 7. And what is 1, 5? Well, 1 times 5 is the same thing as adding 1, 5, right? And I'm kind of illustrating that right here. 1 times 5 is the same thing as adding 5, or it's just 5. It's pretty simple. In the same way that 5 times 1 is the same thing as adding 1 5 times. You can look at it that way if you want to. And what is that? Well, 1 plus 1 plus 1 plus 1 plus 1 is 5. So what I'm saying is you do need to resolve the multiplication first. So don't rely on some acronym like PEMDAS or BODMAS and think those are like a 6-step checklist or something like that. A lot of people memorize those acronyms, but they don't understand that really the true order of operations. Um, the other thing I'll see a lot of people do is they'll get a wrong answer on a calculator and they'll say, well, look, my calculator told me it's 15. I took the calculator I bought at the Dollar Tree or Dollar General and it's telling me the answer is 15. Now, the thing they don't understand is a lot of simple calculators, they're okay for adding and subtracting numbers, or if you're just multiplying a number together. But as soon as you start mixing operations, those calculators are not able to process an entire long expression with mixed operations. Like this, and a good example of that is even on a Windows computer, your standard calculator works in what's called immediate execution mode. So what's going to happen is if you enter this problem in 1 plus 1 plus 1, it just adds those up and gets 3, and then takes 3 times 5 and gives you 15, which is incorrect. But what that calculator does behind the scenes, it's basically going 1 plus 1, and then hitting an equal sign because then it's saying, oh, now you want to multiply. So then it's saying 1 plus 1 equals 3, and then it's saying 3 times 5 equals 15. Well, that's two different expressions, and those types of calculators, the way you have to use those types of calculators is you have to already know the order of operations. You would have to actually multiply 1 times 5 and get 5, and then add 1 and add 1, and then you correctly would get 7. Now, if you switch that same calculator on your computer over to scientific mode, you can see that that entire expression is written out properly when you type it in. There's no difference between the way I entered these two expressions, but you'll see the one on the right, it's only showing the 3 times 5 at the end because it already took 1 plus 1 plus 1 and hit the equal sign for you, basically, because it's immediately executing each operation as they come in. And I understand that's confusing, but that's why a lot of people are getting wrong answers and they're supporting them, those wrong answers, because they don't understand how their calculator works. If you have a scientific calculator, cell phone calculator, you're going to get the right answer because those calculators are already set up and they use what's called expression mode. They can handle multiple operations. A lot of people will say, well, in my day, we were taught to solve left to right. Well, I beg to differ because the order of operations is older than anybody alive. Here's a textbook from 1913, and yes, it's an algebra book, and no, the order of operations does not just apply to algebra. I see people make that argument too. Well, this isn't algebra, so it doesn't apply. You show me the book where it ever said that. That is a false statement. The order of operations applies to algebraic and non-algebraic expressions. So let's make that very, very, very clear. And right here in this 1913 textbook, the fundamental operations are addition, subtraction, multiplication, and division. Indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right, then all additions and subtractions from left to right. Now, the truth is, like when you get to addition and subtraction, you can do those in any order if you understand how the operators work. I see people mess that one up. I've got another video coming up on that, basically going through PEMDAS and how too many people think PEMDAS is a 6-step checklist. And there's people who literally believe addition is always solved before subtraction, and it forces them into some wrong answers. So here's a 1913 textbook, very clear. So um, it's a little bit tiring hearing people say, well, back in my day, we were taught left to right. No, you really weren't. You just forgot what you were taught. Here's a 1950s teacher's edition textbook that got this screenshot here. And basically, parentheses and the other symbols of inclusion are the customary means used to make clear the meaning of a numerical expression. However, mathematicians have agreed on a rule to fall back on if someone omits punctuation marks. This rule gives the order to be followed in performing the operations indicated in the expression. The agreement implies, for example, and then it gives these examples, 5 plus 3 times 2 means the same thing as 5 plus and then 3 times 2 in parentheses, which equals 5 plus 6 equals 11. So right there you have it. Parentheses around multiplication, although that's nice, it's nice to show that. That might help some people who have forgotten order of operations, but we already understand that multiplication has precedence over addition without those parentheses. So these are equivalent statements. 5 plus 3 times 2 is equivalent to 5 plus and then 3 times 2 in parentheses. Both of these expressions end up equaling 11. And it goes through other examples in here. But right here, I mean, right here, it's highlighted. In a numerical expression containing a series of numerals connected by symbols of operation, you agree to follow this order. Number 1, simplify the expression within each symbol of inclusion. Perform the multiplication and division in order from left to right. Finally, do the addition and subtraction in order from left to right. This is from a 1950s teacher's edition textbook. So just want to make that very clear. So when I start seeing things like, well, I don't know about this new math, but back in my day, I'm trying to put a stop to all this mythology out there about that. Your teachers honestly were not that incompetent. They understood this stuff. It's just people forget, but it's really hard to admit forgetting things. I get that. So I hope this video has been helpful. Please consider liking, sharing, subscribing. And I do look forward to seeing everybody in the next video. Take care. Have a great day.